section 6.7, we started to introduce the idea of inverses. So this chapter, we just introduced the idea of inverses, and then in chapter 7, we continue to talk about inverses, and also in chapter 8, we continue to talk about inverses. So we're going to look at some special inverses of functions. So an inverse, recall from chapter 6.7, is when you reverse the x and the y coordinate. So in a table, you would just flip all the x coordinates would become the y coordinates, all the y coordinates would become the x coordinates. And then when you look at an equation, you would flip the x and the y around, and then you would solve for the y, and then that would be your inverse. So in section 6.7, you started to look at the idea of that concept of switching the x and the y around. Now in chapter 6.8, we start to look at what happens when I do the inverse of y equals x squared. So the chapter 6.7, we would take the x and the y, we would flip those around, and then we would solve by square rooting both sides, and I would get y equals the square root of x. Okay? And what we also start to notice is when we graph, say, x squared, the inverse would be taking that parabola and it would be flipping it on its side. And we run into a little bit of problem when we do that. If I take that parabola and I flip it on its side, which would give me something that looks like this. Do that. Let me just give me a second here. We got that. So when I take and I would do the inverse, this is what I would end up with. And I have to do it in two separate steps here. You take that parabola and you flip it on its side. I run into a little bit of a problem when I graph the inverse of an x squared function. If I try to do the vertical line test, what I'm going to notice is that my vertical line test is not going to pass. I'm going to be hitting 2 points basically throughout this whole function when I flipped it on its side. So we run into a little issue that the x squared function, its inverse, really is not a function. So what happens is in the x squared function is we have to limit the function's domain. And to do that, we only would use x values that are greater than or equal to 0. Because then when I take this graph and I find its inverse, it now becomes this green one, which now does pass that vertical line test. So y equals x squared produces a parabola, and the parabola is a function, a-okay. But when you've turned that parabola on its side, it now doesn't pass the vertical line test. So we have to adjust that case for these square root functions. Another way that you can check if an inverse is going to be a function is you can check the horizontal line test. So you can see right away as I go horizontally, I'm hitting 2 points as I go through this parabola. It's not going to have an inverse that's a function, so you do have to do some kind of rearranging with the function in order to make it a function, which in this case we looked at limiting the domain a little bit. So x has to be greater than or equal to 0 in order to make it a function. So today we are looking at square root function. You'll notice all of your square root functions are going to look at like this shape right here. So there's going to be what a square root function looks like. So square root function takes the square root of your inverse, your x value, your input, and you get an output, which is the square root of that x. Now heading back to our notes, we are doing the inverse of y equals x squared. And the inverse of that would be also taking the x squared function, and it would be taking and flipping the x and the y coordinates. So we can see here x squared function 0, 0, 1, 1, 2, 4, 3, 9. Those are all inputs and outputs for the x squared function. The square root function, we flip the x's and the y's. So now the x's become the 0, 1, 4, and 9. And the y's become the 0, 1, 2, and 3. So the y's are just the square root of those x inputs. Now the x inputs, since square roots only work with certain numbers, perfect squares, it's a good idea if you're making a table to only use perfect squares as your inputs, or numbers that'll give you perfect squares when you start to graph these out. So we'll head down, we'll take a look at a couple of the parent function and a couple of the transformations of our square root function.